Hey, we are doing quadratics. Totally just made that up. But we are continuing with our study of quadratics, and guess what my picture for a quadratic function is today? A basketball bouncing over and over again. So those make the parabola, which is a quadratic, the graph of a quadratic. But today we're going to do factoring, kind of like we started last time. This time we're going to use, solving quadratics, but we're going to use factoring to solve quadratics. And this is probably the main way that you'll solve quadratics is by factoring, because oftentimes you'll have quadratics in the form ax squared plus bx plus c. All right, last time we had those special cases where maybe there wasn't a b value, so we could use square roots or graphing more easily. But we're going to use factoring. So it goes back to what we learned last chapter about factoring, kind of the FOIL in reverse. All right, so here's our one. It's not even really vocabulary. It's a property. It's a very basic property, but it's very important to this lesson, and it's called the zero product property. Okay, and this will sound like common sense to you, hopefully, but it states if a times b equals 0, then either a equals 0 or b equals 0, or both a and b equals 0. So we're going to use that property in solving quadratics today. We're going to set one factor of a quadratic, or both of them, equal to 0, because one of them has to be 0 at least. And that'll tell us what the roots are, or the solutions are. So here it is again, if you want to write it a different way. It says for any real number, a and b, if a times b equals 0, then a equals 0 or b equals 0, or both. And here's an example. If we get a quadratic and we factor it and we get x plus 3 times x plus 2 equals 0, well, obviously, one of those two things has to equal 0, either the x plus 3 or the x plus 2. So we set them both equal to 0 and then solve for x. And that's how we're going to get our solutions. So, in words, if two parentheses are multiplied together to equal 0, then one or both of the parentheses must equal 0. So we're going to set both equal to 0 and solve for the variable. All right, and here's how it works. So we're going to say, let's just say it's already the quadratic's already factored like this. And we say, what are the solutions of the equation 4x plus 1 times x minus 2 equals 0? So again, it's important that it's equal to 0. So what we're going to do is we're going to set each of them equal to 0. 1, 2, equal to 0. And solve each of them. One or two-step equations. So this is solving it next to each other, the vertical. I would usually do it underneath. But we're subtracting 1 from both sides in this red one. And then we're left with 4x equals negative 1. We divide both sides by 4 to get x equals negative 1/4. For the yellow one, it's just a simple adding 2 to both sides, and you get x equals 2. So then our solutions, x equals negative 1/4 and x equals 2, that would be our two solutions. That's what x equals. And that's how you solve, that's how you use the zero products property. So why don't you try it? What are the solutions for each of the equations below? Pick two of them. Pause it and pick two. And I will show the answers in a second. All right, so each one you can look at what ones that you chose. I set each of the factors equal to 0 because if the whole left side is equal to 0, then obviously one of the factors has to be equal to 0. So let's set them both equal to 0 and then solve. And then it's all just solving in one or two-step equations. For the first one, you end up getting x is negative 11 or 5. Second one, x is negative 3/2, which would be negative 1.5 or 4. And then last one, we have y's instead. It'd be y equals negative 1/2 and y equals negative 14. So that's using the zero products property. Now we're going to use that property to solve quadratics. So when we're solving by factoring here, this is the main method of solving quadratics, you can also use that zero product property for problems of the form ax squared plus bx plus c, as long as the equation can be factored. So we're going to have that, make sure that's set equal to 0. And if we can factor it, then we can solve it. So here's the procedure. Put the terms in descending order. So make sure it's ax squared plus bx plus c. Factor out the greatest common factor if there is one. So I'm going to make that note. Oftentimes there might not be one. Find the target numbers. Set up your parentheses. And check your answer by folding if you want to make sure that you have factor it correct. Set each of the parentheses equal to 0 and solve for the variable in each. And then we have our two answers. So that's how you solve a quadratic by factoring. As long as we can get it into two factors, or two or three, like when we factor it, then we can, and their set equals 0, we can set each of them equal to 0. Okay? So we have our first example. What are the solutions of the equation x squared plus 8x plus 15 equals 0? So that's a quadratic. It's in the form x squared plus bx plus c. So we're going to take that, let's try to factor it. So we want to find numbers, remember that multiply, let's see, I have it here. Multiply to equal 15, because 1 and 15 makes 15, and add to equal 8. So let's see, 5 and 3, there we go. That's the ones that I got. Target numbers are 5 and 3. Those multiply to equal 15 and add to equal 8. So we have x plus 3 times x plus 5 equals 0. And now we're back to what we just did on the last page. We can use the zero product property. Set them each equal to 0 and solve them. One step for each of these. Subtract 3 on the left one and subtract 5 on the right one. And you end up getting x is equal to negative 3 or x is equal to negative 5. So there's our solution set. One of those are the two values for x that would work. So why don't you try it? I have two examples. Choose at least one of them. Well, why don't you try both? Try both and pause it. And then I'll go through them in just a sec. Alright, so this first one is actually very simple. I need to find one that multiplied to equal, and I'll do this, because I want to go through the second one with you. Oops. Not sure what happened there. However, find one that multiplies to equal 14 and adds to equal negative 5. Negative 14 and 5. Negative 5. And those two numbers are negative 7 and 2. So I set up my parentheses. I got x equals, or x minus 7 times x plus 2 would equal 0. And when I go about that, I set each one equal to 0 and solve it. And I got two solutions, 7 and negative 2. Now the one on the right is a little bit more, it's one of the trickier ones to factor. So first of all, we need the right side equal to 0. So don't forget that you have to add 18 to both sides so that you have the quadratic set up. So we have 2x squared plus 15x plus 18 equals 0. So now we have it equals 0. Now we can try to factor it. But here again, we have an a value. So we're looking for something that multiplies to equal, whoops, I'm going to do that, multiplies to equal 2 times 18, which is 36, and adds equal negative 15. So the two numbers that I got for that, let's see, are negative 12 and negative 3. Multiplies equal 36, add equal negative 15. So we do the x minus 12 and x minus 3 equals 0. But remember, we have to take this 2 and put it underneath each. This would be the bottoms up method. This is the one that I like the best. Now, if either of them can be simplified, we're going to simplify it. This one's fine. This is going to stay as x. And the one on the left can be changed to x minus 6. So that's going to be x minus 6. So then the one on the right is where you do the bottoms up. And you bring that since that can simplify, you bring the bottom up to the in front of the x. So we have x minus 6 times 2x minus 3 equals 0. And now we have two factors set equal to 0. And you can check by just doing the FOIL method to see if we did that right. But then we'll have x minus 6 equals 0 and 2x minus 3 equal to 0. And we can solve. So plus 6 on both sides. So we get x equals 6 for this one. And then plus 3. And then divide by 2. Sorry, 3. That's a 3 right there, I promise. Divide by 2, you get x equals 3. Sorry, this is supposed to be a 2. 3 over 2. So our two solutions for this one are 6 and then 3 halves, or 1 1/2. Alright, took a little bit more work for that one because there's a little more work to factor it. But then once you factor it, it's again using that zero product property to find the solutions. So, little application here. And you're solving real world problems. Here's a situation. And we'll just work through it together. Um, but it's worth taking note of because I'm going to ask you to do some of this on your own. It says you are constructing a frame for a rectangular photo shown at the right. You want the frame to be the same width all the way around, and the total area of the frame photo can be 315 inches squared. So what should the outer dimensions of the frame be? We know the inner dimensions are 17 by 11. We need to figure out what the outer ones are so that equals 315. So we know we're going to have, um, we have, so what I was saying is, sorry, the length of this whole thing, we know it has 17 in it, but it also has the same width all the way around, so we're going to call that x. So that's where we get the 2x, because there's an x here and an x here. We have x, so it's 2x's plus 17. And I don't know if I can fit that on here. That looks like 11, but it's supposed to be 17. Okay? And then the width of this, or the length, I guess the longer one would be the length, but we have, oh, sorry, I apologize. This is supposed to be 2x plus 11. This one is 17 width, and it is 2x plus 17. So those would be our two factors. Those have to multiply to equal 315. So we set that up like this. 2x plus 11 times 2x minus 17 equals 215, or 315. Now we're going to have to do a couple pieces of work with this because we don't have 0 on the right side. And we can't just subtract it because that wouldn't make a quadratic. So we're gonna FOIL this out. We get 4x squared plus 56x, because when we get the 22x and then the 34x, that makes 56x. And then plus 187, that equals 315. Now we can subtract 315 from both sides. Okay? And we get 4x squared plus 56x minus 128. And now from there, we can factor out a 4 to make this easier on ourselves. That's the greatest common factor, if there is one. Well, this is 4, and then if you factor that, it would be 4, and then x plus 16 and x minus 2, because it multiplies to equal negative 32 and adds to equal 14 would be 16 and negative 2. So now we have 3 factors, actually, but the 4 doesn't really count, because 4 doesn't equal 0. So we have x plus 16 has to equal 0, or x minus 2 equals 0. And when you solve that, you get x equals negative 16, or x equals 2. So if you look at it, the picture, x can't reasonably, logically, looking at what x is, this width around here, cannot equal negative 16. You can't have a negative distance. So the only logical answer is 2. And that's where this comes in real life here. So the only reasonable answer would be 2. So the outer dimension of the frame are 2. And if you plug that back in, it should work out. Okay? And we're going to end it at that. I'm not going to have you do it on your own. But that's a great example of how you can use quadratics and solving quadratics by factoring to figure out like a specific distance here. All right? And that is all we have for this lesson on factoring with, or solving quadratics with factoring. So revisiting that goal, we wanted to just solve quadratic equations by factoring, and we used that zero products property to do so. All right, that's quadratics. See you next time.